Hello students, today I'm going to teach you applications of partial differential equation, which is very important. In this we can say we are going to study wave equation, heat equation and Laplace equation. So all this will come under the applications of partial differential equation. So already you have studied partial differential equation. If you have not studied, go to the YouTube link. You will get a playlist. In that you are going to get partial differential equation. We have solved so many examples, which is very important. Please see that you practice this example. Today I am going to have the derivation of some different type of classifications in partial differential equation, students. Is it clear? I think we are going to start with the next thing. Yes, in the introduction I am going to tell how one dimensional heat equation is there, wave equation is there, and Laplace equations you are going to come across. Is it clear, students? Get the solution of partial differential equations. Yes, students, I am going to teach you today applications of partial differential equations. Here we are going to come across heat equation, wave equation and Laplace equation. So here we go with some other different some more equations. So here one can see very easily how hot in a conductor, how hot is going to convert temperature from one end to another end, it is going to transform. So in this transformation you are going to come across the waves. You can just see here the curve. You can see how a curve, a temperature goes on decreasing as you can see in this conductor. In a rod, the temperature goes on decreases in a rod. If you take some rod, suppose if you take some, this is as a rod, from one end to the another end, if you are making one end temperature rises, then this from this end to it will go to the other end. This is a graph, very simple, it is given. It will be very fast, so that we are going to derive this equation. So this is the diagram. You can see from hot to cold that heat is going to transform. Okay, students, so this is what we are going to do the derivation, and here we go. Yes, so this is our one dimensional heat equation, wave equation and Laplace equation, how the heat is going to transform, and we are going to see partial differential equation which involves partial derivatives with respect to two or more than two independent variables. Partial derivatives with respect to independent variables are denoted by subscript. So you can just see there are two independent variables already discussed in the partial differential equation. I will send the link and notes will be uploaded. So this question is very important. Please practice this equation. Before deriving the one dimensional heat equation, I am just giving the introduction to partial differential equation. What are the applications and variables? There are the simple examples. Here you can see, students, we have taken z is equal to f of x, then just differentiate this. So these are the few examples, 1, 2, 3, 4. So this is how we denote and write the partial differential equation. In this classification, students, very important, in all the derivation you come across this equation, that second order linear differential equation of general form. So this is the general form I have given. So it says that these are classified by values of discriminant b square minus 4ac. Please remember, this is GATE exam or in competitive exams, this question will definitely appear for 1 marks, and for your quiz also you are going to get this type of question. B square minus 4ac is greater than 0, it is hyperbolic. So it's a wave equation, we can say. B square minus 4ac is equal to 0, it is parabolic, which is example of heat equation. b square minus 4ac is less than 0, it is elliptic. Example for Laplace equation. They may give any type of equation, you will practice 1 marks question. This is the simple wave equation. You can see this is how the wave is going to form with respect to one dimensional wave equation. Heat is going to transform from one end to another. This is what they have given the wave equation for that. Subject to various assumptions, damping force such as resistance are negligible. The weight of the string is negligible. Tension in the string is tangential to the curve of the string at any point. So we have the string performs small transverse oscillation, that is every particle of the string moves strictly vertical and such that its deflection and slope as every point on the string is small. So this is all we have for partial differential equation. Please remember we are discussing partial differential equation. So next we can see we are going to use the simple equation by applying Newton's law for motion to a small segments of string. This is a simple equations you have to remember. To determine u x comma t uniquely, so everywhere for all the derivations we are going to take u bracket x minus t uniquely. So this is an initial definition. So you can just see very important. Initially you can see motor cycle is there, temperature is initially it will be start with 0. And acceleration is there, any strength and stress in string is there, it will start with 0. So you can see the graph also I have already shown you. So these are the some initial conditions. Please remember these initial conditions. And how the weight of the string is there. This is the equation for that weight of that strings. Damping force proportional to the velocity of the string. So this is one dimensional heat flow. What is the application? Heat flow from higher temperature to a lower temperature. Please remember this. We are going to use this in the derivation. And the amount of heat in a body is properties to its mass and temperature. The rate of heat flow across an area is proportional to the area and to the temperature gradient normal to the area, where the constants of proportionality k is called the thermal conductivity. This is the equation what we have. So this equation, to remember in the heat flow I am going to use this equation. So previous slide you can see I have given equation. This equation we are going to use for the wave equation. So whenever wave equation we are going to derive, we are going to come across these initial conditions and these are the equations. For heat dimensional we are going to write this equation. And Laplace equation, yes students, the notes and all the details will be given in the description box. Please comment on the video so that it will motivate me to make such videos again and again so that you get all the information. So I have already told you that there are 3 derivations which will definitely come in the examination, students. So this we have Laplace equation, type equation. Here we have determined the electric field. So everyone come across electric field E in the region which is Coulomb law or Gauss law, when the charge distribution is specified in a region or using the relation E is equal to minus daba V, when the potential V is specified through the region. However, in practical cases, neither the charges distribution nor the potential distribution is specified, only at some boundaries. This type of problems are known as electrostatic boundary value problem. For this type of problems, the field and the potential V are determined by using Poisson's or Laplace equation. Yes friends, I just mentioned this is Laplace equation we are going to derive. Laplace equation is a special case of Poisson's equation. So please remember this. So these are the equations we are going to use in the derivation. In the next derivation we are going to use this type of equations. Please remember this. Cartesian coordinates is there, cylindrical coordinates are, spherical coordinates are there. These are the 3 coordinates. What is this application, students? Yes, everyone wants to know what is the application. Just I have made a list. I have gone through various books and have collected this information for you. Yes friends, this video is completely for your understanding, why we study these things and where it is applicable. Everything I am going to explain, and we are going to derive the equations one by one. So this is the application of Laplace equation. Using Laplace or Poisson's equation, one can obtain potential at any point in between 2 surfaces. When potential at 2 surfaces are given, we can also obtain the capacitance between these 2 surfaces. Yes friends, thank you so much. So this is a small presentation I have done. So please see that everyone go to the rewind the video once again, go through the slides. If any doubts are there, please ask me. If you want the notes, I will upload it. See that you practice this example, students. So this is application of partial differential equation. Introduction part I have finished. Now we just see the general second order linear partial differential equation is two independent variable is of the form. So I just said it's a two independent variables. So they are x and y are two independent variables. This is the equation where for all the derivations we are going to keep this same. So please remember. Yes, many students ask that what type of questions will come in the examination. Yes, friends, this is a small questions I have prepared. Derive one-dimensional heat flow with solution of heat equation. This is a very simple question they ask in many exams. Suppose your internal exams are there, OB exam is there, and for your SEE exams, CIE exams, in VTO exams, and for various colleges, and you can see in the GATE exam also they ask this equation. Yes, when I went to write the exam, GATE exam, students, I have come across what is the one-dimensional heat flow with some conditions. So this first we'll derive this one by one. It's very very important. You practice it. The notes will be uploaded. Please comment on the video. Any doubt is there, we'll just share it. You can see I have prepared this partial differential equation application we have, and yes, we are going to derive this now. So whenever they give such type of questions, students, first you have to derive the equation, then you are going to find the solution. Please remember, derivation is different, derivation of solution is different. So there are two concepts you have to remember and represent as it is in the exam. Yes, friends, many of them they say, sir, so many things, how you are going to remember? Yes, your memory is very very less. Use it. I have made it very simple and small. Explanation part, you write it in your own words. There is no marks for such explanation. You write it in your own words. But please remember this, students, whenever you are writing any derivation or equation, please write it correctly. Don't make mistake in the equations what I am going to do it today. Okay, this is a very simple equation they asked. Derivation, we are going to see one-dimensional heat flow. Yes, friends. Here we start. Consider a homogeneous bar of uniform cross section alpha. I will take it cm square. Suppose that the slides are covered with the material impervious to heat, so that the streamline of heat flow are all parallel and perpendicular to the area alpha. Take one end of the bar as the origin and the direction of the flow as the positive x-axis in the figure given below. Let rho be the density in grams per second meter centimeter cube. The specific heat, S is the specific heat, and K the thermal conductivity. So this is what they have given. Yes, and so here, sorry, R is the thermal conductivity. So this is the explanation you have to write in your own words. Don't write as it is, but see that whenever such derivations comes, you draw the diagram. So what I say that, just a minute. Okay, here we see, just take the pen. When you draw this diagram, students, please draw the diagram neatly. That's the impression in the examination, and examiner wants you to draw it correctly with the pencil. Please remember, these are things very very important. Now when you see, look at this diagram, so what I'm saying is, this part where this alpha is the area, here I'm going to take the cross section area. Here I'm going to give the temperature. So here temperature rises, so here I say this temperature is some S is the specific heat. Is it clear? Okay. Then with this specific heat, this temperature rises on this area alpha, and it will start conducting this bar alpha. So current heat passes from this alpha point O to X. This is a simple explanation, you can write it in the exam. So here this bar you have the density rho. So it just mention this, very important. Rho is the density. And here you can see this is X is the distance. This is a distance, and delta x or dou x, delta x is nothing but again change in the distance. Here we can see, students, this is a cross section area. I am going to take only this cross section area. In this area we can see the temperature from point, I'll just say this is N to M. What is the temperature? Here we are going to get the difference. The difference in the temperature will be always R1 minus R2, because R1 at point R1 temperature is more. So you can see in this temperature will be more, and when it travels distance delta x, the temperature decreases. Therefore R1 minus R2, I am going to take the temperature difference of this. Okay, so this is, you give the explanation, this is enough. No more explanation, 4-5 lines is more than enough. But you see that you understand the how the heat flow takes place in this bar. Then here the main part of the derivation start. I say that let u x comma t be the temperature at a distance x. Yes, when it starts from 0, here I am going to take the temperature, initial temperature. This is the initial condition, u of x minus t from O. So here it starts. Okay, if delta u be the temperature change in the slab. So this is change in the temperature, this is change in the distance x, delta x, and u is the temperature. So change in the temperature, delta u we will take. So thickness delta x of the bar. So depending on how much it is going to take the distance, that much change takes place in the temperature. Then the quantity of the heat in the slab will be equal to, yes, what is the quantity you are going to change in this, friends? Please remember this. In this, just a minute, I tell you how to remember this. So when you see this rod, friends, I say that this is the extra part for you to understand. I am going to take the fundamental principle of, so this you have to remember, this is by fundamental principle of heat conduction. What it says, this is equal to, you get some constant here in this, which is a specific heat constant. I think everybody have come across specific heat constant. So some specific heat constant is there, and then from temperature 0 to O to X, what it requires, yes, temperature changes according to the area. So I say that area of cross section So this is how, what all things are being affected by the temperature, the specific heat, area of the cross section, and thickness is very, very important. Thickness is that change in the temperature in the slab, change in temperature in this slab depending with the density. Very, very important. Density is very, very important in slab. This is known as, which is known as or thermal conductivity. This is by thermal conductivity. Okay students, so this is by thermal conductivity. Here I say one by one specific heat constant. Just now I told in the diagram, one can easily see what temperature, quantity of temperature or heat get changes or it is affected. It's very very important. So why we write this equation? That's what I'm saying. S is nothing but the specific heat. So specific heat I'm going to multiply. Next we going to take the cross section area. So this area I'm going to take this as delta x. So I have to multiply that term. Thickness I have taken here alpha. Alpha is the thickness. So I will take alpha as the thickness. Here I have taken alpha. Cross section area, that I am going to multiply. And what else is going to affect the in this rod slab? Yes, density I have taken. So S is specific heat, rho is nothing but density, alpha is cross section area, delta x is nothing but the distance, and dou u upon dou t is nothing but the change in the temperature. So you can just see temperature doesn't remain same from one end to another. N and M, if you take the temperature, it will change. So that change I have taken rate of change of temperature, that is dou u upon dou t, which is nothing but the heat in the slab. So here I say heat in the slab is R1 minus R2. So this equation is very very important, where R1 and R2 are the rate of inflow and outflow. Please remember this one. So this is very very important part. You write it orally, but this equation you please remember, you don't miss this equation. Keep this equation number 1. Okay, after keeping this equation 1, then I say that, just take a pen. Okay, I'm going to derive now one dimensional heat flow. Now we have come across the quantity of heat in the slab we have seen. Is it clear? Okay. So here I say rate of change of heat I have written R1 and R2, rate of inflow and outflow. So now I say this R1, it has the temperature minus R alpha at point R1, change in the temperature dou u upon dou x at point n, at point n. So this means that R1 is directly proportional to some constant I have taken. Negative sign because temperature is in a opposite direction, therefore I have taken negative. Constant into, it is directly proportional to the cross section area, and into change in the temperature. So this is for your understanding, I am writing this part. It is not required to write in the exam. So this is R1, this is I am going to substitute in the equation. And please remember what is R2. R2 will be what, students? Yes, it is again constant, specific heat constant I am going to take here R. Alpha is again cross section at point M. What will be the change in temperature? It is dou u upon dou x, x plus delta x at point M. These are the two equation I am going to substitute in the equation, and I am going to get the heat equation directly. Very very easy derivation this is. Please remember, negative sign is nothing but the opposite direction of the temperature. Hence just substitute in the equation. The quantity of heat flow, just in the previous slide you can see the quantity of heat flow is nothing but R1 minus R2, which is, yes, specific heat is going to change, temperature changes takes place. Rho is the density, alpha is the cross section area, delta x is the change in the distance, and dou u upon dou t will give you the change in the temperature. So all this will give you R1 minus R2. So R1 minus R2, I'm going to substitute this above equation. From above equation, I'm going to substitute. Just substitute the equation. Minus R1 alpha dou u upon dou x. X minus into minus, it will become plus. Please remember, don't make mistake how sir has written this plus. Don't get confused. Minus into minus is going to become plus. Just I am substituting this to equation. So alpha dou u upon dou x, x plus delta x. That's it, students. Now we'll just simplify this equation. Is it clear what all the common things are there? I will take it outside and we'll simplify this equation. So here one can easily see alpha is there, so alpha I will take it outside. So what all things are common? Yes, friends, R1 is common. Just I will take it down. Here the derivation parts, friends. Okay, R1 is R1 alpha is common, so just take alpha outside. See here R1 and R2, they are the R1 and R2. Just substitute the equation, friends. R1 and R2 I have to substitute. Once again R1 and R2 you will not get here. Okay? Or you will get R1 and R2 have substituted the equation. Please make the correction. So here, what is common here, students? Yes, it is R is common in both the equation. So I will take out R. So R I will take it out. Alpha is common. Alpha I will take it outside. Okay, R and alpha is common. Okay, now I'll write the equation like this. First I will take the positive part, so dou u upon dou x, x plus delta x minus dou u upon dou x, x. Just I have interchanged this and I have taken the common part. In this you can see I have RHS said yes, specific heat rho density, alpha cross section area, delta x change in the distance, and dou u upon dou t change in the temperature. So on both these sides you can see alpha and this alpha is common, so I'll just alpha is common, so I'll just remove alpha, and yes, here we have alpha common, I have removed alpha, and remaining things I will bring this on right hand side, this I will bring it on right hand side. So what is remaining here, students? Dou u upon dou t. Yes, change in the temperature. I want to see one dimensional heat equation, students. Dou u upon dou t is nothing but one dimensional heat equation. Change in the temperature I wanted to calculate. So this is equal to minus, I have taken inside in this, so it will become plus. So here it will be R upon S rho, and delta S also I will take it on this side. So this will be like this: dou u upon dou x, x plus delta x minus dou u upon dou x, x divided by delta x. So this is the equation, students. Please remember this equation. I'm going to substitute. I'm going to taking limit as delta x tending to 0, and I'm going to substitute r divided by s. Rho is some constant c square. I will just take this as a c square. Okay, so therefore, yes, students, therefore what will be the equation, students? When I substitute this values, I will going to get this. Therefore dou u upon dou t is equal to c square When I apply the limit, students, limit, if you come across the limit unit, in that limit as delta x tending to 0, dou u upon dou x, x plus delta x minus dou u upon dou x, x divided by delta x. This equation, students, please remember this. This is nothing but dou square u upon dou x square. This is a formula. Please remember this formula, students. Formula written on right hand side. So please remember this formula. When I substitute this equation, students, I am going to get this as dou square u upon dou x square. So this equation is nothing but this is one dimensional heat equation. So this is very simple derivation we have. Just go through the derivation once again. You will understand very easy it is. I will repeat this once again. So what is there in this derivation, students? Please remember, just one dimensional heat equation they will ask. Derivation, it's a solution. I will just continue this lecture. So just explain this diagram and give the description. Say that at this one, initially the temperature is u x minus t from x to 0. Delta u is the change in the temperature. Remember this. Then what is the quantity in the slab? By fundamental principle of heat conduction, remember this one line. And then what temperature takes place, what is the proportionality for the temperature to changes takes place, that is the constant is one you have to remember. Area alters the temperature, thickness alters the temperature, and then density in the slab alters the temperature. This is by thermal conductivity. All these things will proportional to the temperature. So you have to remember this, and you are going to get this equation here. This is the equation you will get, and substitute R1 and R2. R1 is nothing but the at point n what temperature changes takes place. So R1 at point R1 at point n, R1 will be equal to minus R, that is only the direction. It is some constant, specific heat constant, and into cross section area I have taken alpha, and dou u upon dou x, change in the temperature, rate of change of temperature we can say we have taken. At point n the distance is x, so we have mentioned here this is x. Similarly R2 will be equal to minus R. Again remember this proportionality constant. R1 at point R2, it is again constant, some constant I am going to get, that specific heat constant. So here I am going to take minus R. Minus R is just a negative opposite direction of the temperature. So as why it is opposite direction is the same, as length increases temperature decreases. So this is why we get the opposite direction. And next we have into cross section area. I have taken here cross section area alpha. Change in the temperature, dou u upon dou x remains same, but at point m the distance is x plus delta x. That is what you have to remember. The substitute R1 and R2, simplify the equation, you are going to get this one dimensional heat flow. That's very simple, friends. Okay. After this derivation, immediately you are going to solve the heat equation. Yes, students, please remember the heat equation. It will take another 4 or 5 minutes. You can do it very easily. Yes, so I will take now heat flow. So after this you are going to take the solution of the heat equation. So what will be the solution of heat equation? Within 5 to 10 minutes you can easily solve this problem, students. Okay, you have to understand the equations here. Assume, so write this sentence in the exam. Assume that a solution is there for this equation. So I say that dou u upon dou t, I will going to take the heat equation c square dou square u upon dou x square. I will take this equation number 1. This is equation for heat flow. It is of the form, I say that this is of the form, yes friends, you have to write this of the form u of x comma t. Already I told you it's a two variable, students. Please remember, partial differential equations, any equations you take, there will be always two variable. Here I am going to take x is the distance and t is the whatever temperature we are going to get. Please remember this, x is the distance and temperature, that's it. Okay, according to the temperature, as distance increases, temperature decreases. Please remember this. So this I say that this is x and t, x and t, that's it. What is x? X is a variable with respect to x, and t is a temperature with the variable small t. I will take it. Okay, I say that where x is a function, x is a function of x alone. So no need of writing, you have understood that. Okay, but you have to remember this, that it is a function of x and t is a function of t, temperature only. These are the variables you have to going to select. Yes, now I'm going to substitute this equation. I'm going to substitute x and t function in equation 1. Okay, let's just substitute the equation in 1. So what will be the equation? Yes, here the equation will be substituting in 1. We get what we get here, friends. Yes, we get that x remains as it is, no change, and dou u upon dou t, it is t dash I am going to take. So dou u in the equation 1, you can see dou u upon dou t, it will become u is a function of x and y, so this will be dou u upon dou t as some x into t. X is constant, so I will take it out x. Just I am giving the explanation, no need of writing this. This is rough work, you can say, or this is substitution how we have done. So x is constant, I will take it outside. So then dou t upon dou t will remain, which I will write this as t dash. So this is t dash, you will understand here what I have written, x t dash is it. Okay, so this is equal to c square. From equation 1, students, again please remember the next value I am going to substitute dou square u upon dou x square. So again I am going to substitute this value here, students. What is u? I have taken x into t, and now again here t is constant, so I will take out t outside. This is t into dou square x upon dou x. So double time differentiation, so t into x double dash I will take. So here I will write t x double dash. Is it clear, students? So I will take this equation number 2. So this is how we are going to find the solution of the heat equation. Please remember this. Now I am using the separable variable. I will make separation where one side it must be always x and one side it must be t. So in this side, left hand side, I will make x. So this is x double dash divided by x. I will take it x. I have brought it this side. This is equal to c square and t. I will bring it on this side. So I am just interchanging it. 1 divided by c square. 1 divided by c square is constant into t dash divided by t. This is by separable variable. What is separable variable method says? One side you have to bring right hand side one variable, left hand side one variable. That is what I have done here. Now in this I say that this is equal to some constant. I am going to take this as r. Some constant. I say this is r is nothing but r is some constant. So that will make my solution very easy. Now I will just separate this in two parts. Yes friends, I am going to separate this in two parts. What is that? X double dash upon x, we say this is r. This is one way. And t dash upon c square t will be r. Either this is correct or this is correct, same. These are equal means I am going to equate this with respect to r, so I have taken this r on both the sides. Now we will simplify this equation. Simplifying the equation, we get what we get here friends. Yes, we get here, so just take r on the right hand side, so this will become, just I will take x on this side, so x double dash is equal to rx. Similarly with respect to t, I am going to take on this side, so say that t dash is equal to r c square t. I will substitute in this both the equations friends. In this both equations I am going to substitute the values of differentiation. So what we are going to consider? Yes, what is x double dash friends? Please remember this x double dash, I am going to take d square x upon d x square. So this is capital X, so therefore x double dash I have written like this, and t dash I am going to take this as dt upon dt. Just substitute this two equations friends. Substituting, so I will write this equation as d square x upon d x square. Rx I will bring it on left hand side, so this will become minus Rx is equal to 0. Similarly with this equation, dt upon dt is equal to, or minus, I will just take out this r on this side, so minus r c square t is equal to 0. So now using auxiliary equation friends, one can easily find this equation simple way. Okay, now t and r, what are the equations we are going to get? So we don't know what is r. R is positive, r is negative, or r is 0. That depending on the conditions it will change. It is a specific heat, please remember this friends. R will be positive if the temperature at both the ends are same. Correct, R is positive. This is one condition. R is negative as temperature increases, yes, the distance increases, temperature decreases. So it is in the opposite direction. And there is no temperature. In the rod there is no temperature. So what will be a specific heat? R will become directly, it will become 0. So these three conditions I am going to apply one by one. So first condition I am going to take, I say that when R is positive, so some positive value, I will take this R as some p square be the positive value. Say this I am going to consider, I am going to take this, I am going to say that, consider, I say that p square is some positive value. In this both the equations I am going to take this as equation number 3, and I am going to this, in both the equations I am going to substituting in 3 and 4. So just substitute this equation in both the cases. You will get here d square x upon dx square minus p square x is equal to 0. Similarly here I will get dt upon dt minus p square c square t is equal to 0. Okay, now you want to get the solution. Please remember this friends, whenever you are solving this type of equations, you always consider the auxiliary equation. What is auxiliary equation friends you have come across? So this d square upon dx square, here I am going to write d square upon dx square, I will substitute this as some d square. So this is going to become d square minus x, I will take it common, p square, x is equal to 0. We want to find the solution. This is the way we have to find the solution, students. Please remember this. So this will become d square minus p square, x is equal to 0. Similarly, in this case, I will take d upon dt is equal to d. So this will be, I will take t common in this equation. So this is d minus p square c square. T I have taken 0. So if you don't understand, friends, please repeat the video. Please rewind the video once again and try to solve the equations, students. Okay. So then I will write the auxiliary equation. So how you are going to write the auxiliary equation, students? Please remember how you write the auxiliary equations. Auxiliary equations will be written like this. Let's say that this auxiliary equation is written in this way. So whenever d is there, wherever d is there, it will become m. So that implies m square minus p square is equal to 0, and here m minus p square c square is equal to 0. Now simplify this, friends. Here I get m is equal to plus or minus p. So here you can see square will go minus. If you bring it on right hand side, it will become plus. We say that here roots are real. Okay, here I will take p is equal to minus. If I bring it on this side, it will become plus. It will become plus p square c square. It is p square c square. Here roots are real and pair or twice. So therefore I am going to take m1 is equal to minus p and m2 is equal to plus p. So there will be two roots, plus and minus. Whenever there is square, we always consider this minus and plus. So depending on this, what is the solution? I think you have come across the solution. If you want more detail on how we are going to take the partial differential equation, auxiliary equation, and the solution, what are the real roots, what are the imaginary roots, all this I am going to share in this video description. So please go through that. I am going to give the formulas for real roots, what are the solutions, what is the complementary functions, and how the auxiliary equation is written. I have solved many examples on auxiliary equations, compensatory functions, finding their solutions and general solutions with respect to imaginary roots, real roots, equal roots, repeated roots. All these examples I have already solved. Please go through that video in the description box. Yes, friends, any doubts are there, please comment on the video. I will go through it. So what will be the equation, friends? This is x is equal to c1 e raised to, first I am going to take m1, so it is minus p x. This is the general equation we have from formula. C2 e raised to, here I am going to take now m2 is px. So this is the solution. Direct we get the solution using the formula. Similarly here m is equal to only 1 is there. So one solution we get. So that is t is equal to, and t is equal to c3 e raised to c square p square t. Here t is the variable, here x is the variable. How we get this solution, students? Already we have discussed in many examples. I will share that examples also and their formula, how we get the solution. So this is the first condition when r is positive. Yes, friends. Immediately we'll go to the next, when r is negative. Okay, so I say that the case 2 when r is negative. So So this is the solutions we get from. That's it. The heat equation is over. And R is equal to, I will take here some minus P square. I just consider it. Myself, I am going to consider this equation. Okay. So again, go through the equation, students. See there. I am going to substitute in that equation. So here I will take dou square x upon dou x square. Minus into minus will become plus. P square x is equal to 0. And this side, friends, yes, it is dou t upon dt. Minus into minus will become plus. P square is equal to 0. Please remember the equation, friends. P square c square t. So it is P square c square t is equal to 0. Okay. Again, I am going to write this equation in terms of d. Differential equation. Just now I am substituted, so I will write this as d square. That implies d square plus p square. I will take the constant x outside. X variable I have taken outside, so d square plus p square x is equal to 0. I am going to find the solution. Similarly, on this side, it will be d. What is common part? T is common, so I am going to take t outside. It is p square c square t is equal to 0. I am going to write the auxiliary equation. Please remember the auxiliary equation. D is going to become m. And what will be the auxiliary equation for this? It is m square plus p square is equal to 0. This is the solution what we get. And similarly on this side, it is m plus p square c square is equal to 0. So now what will be m, students? Yes, m is now going to become minus p square, and if we take the root, it is going to become an imaginary root. That implies m is equal to 0 plus or minus p. Plus or minus, we will take here p square only, so that let us not remove the square root from this. So it is going to become plus or minus ip. So root minus 1 I have taken, root minus 1 it will be, I have taken, p square will remain as it is, no change in p square. So this this is imaginary root. So imaginary root, what is the formula? Already I have given, so please follow that. So alpha here, alpha, this is going to be compared with imaginary root alpha plus or minus I beta. Alpha is 0 and beta is p square. Therefore, yes students, what will be the solution? Solution will be x is equal to c4 cos px. P will go ne px plus c5 cos px. So this is what we get the equations from. Okay, fine. If you take the square root, minus 1 will become I and p square will become square root of p square. I will take p only. Again, you will get confused. So I will take here p square. Square root of p square I am going to take here p. Okay, so I will simplify this equation now. M plus p square c square is equal to 0. Here I will get directly one equation, that is m is equal to minus p square c square. So what will be the equation here, students? Yes, here directly I will get here a solution, and t is equal to, so there is no imaginary root, this is only one real root. I am getting real root. Therefore, what will be the formula? Please remember the formula. It will become t is equal to c6 e raised to minus c square p square t. This is the solution. This is the solution. Is it clear, students? So this is how we get the next solution. Okay, so next condition, please remember, next condition what we have? Case 3. I'm going to solve now case 3. So please take the case 3 now. I'll take here case 3. Okay. When R is 0, means there is no change in specific head, so therefore R I am going to take here 0. When you take R 0, students, directly you will get here, substitute in the equation, so dou square x upon dou x square. I'll take here 0, that is d square will become 0, d square is going to become 0, which is 2 real and repeated roots. Yes, friends, real and repeated roots I am getting. So therefore auxiliary equation I am going to get m square is equal to 0. So here that implies m1 is 0 and m2 is 0. That implies what will be the solution, students, for this equation? Solutions will be complementary function, that is x is equal to c7x plus c8. This is the solution. Similarly, if we substitute in t equation, you can see directly dt upon dt will become directly 0. So only one solution you will get. Auxiliary equation you are going to get this as m, or this, or d is equal to 0 or m is equal to 0. Auxiliary equation is 0, so therefore what will be the solution, students? T is equal to, directly only one equation will get, that is a constant C9. So that completes the derivation, students. All the conditions we have simplified. Therefore please remember what is the solution for the heat equation. So I will write directly according to the substituting solutions in the heat equation. U is that decreases with increase of temperature T. Therefore I can say that this x and t, if you take with respect to u is equal to x into v, what we have already done, so that equation can be written like this. So therefore thus are possible various possible solutions, various possible solutions of heat equation R. So here I am going to take the equation u into x into v. This is our solution. So one by one. So in first case 1, what is u? U is changed. So I say that c1 e raised to px plus c2 e raised to minus px into c3 e raised to c square p square t. Similarly in case 2, what is u is equal to x into v. So the solution is c4 cos px plus c5 sin px into t. T is c6 e raised to minus c square p square t. And in case 3 again u is equal to u into t, x into t. What is x, students? Here in the above equation you can see x is c7x plus c8 into c9. These are the solutions. So please go through it once again. Of course these three solutions we have chosen that solutions is a constituent with the physical nature of the problem, students. So these are the equations. We have find the solutions for the equation. So please go through this equation and